Hello everyone, I am Dr. Sapna Katyar, Professor in ECE Department at ABES Institute of Technology. This is lecture 1 of subject Electronics Devices. See, this subject is very important and the subject is being introduced for the students of second year, ECE, ENC, EI, IC and related branches. So, you must read this subject very carefully because this is the foundation of electronics. Let us begin. In today's lecture, you are going to study about the introduction to semiconductors. What is semiconductor, how many types of semiconductors, how to classify it. So, all these things you are going to study over here. Let us begin. Semiconductors and its classification. Some of the things you must have studied in your schools as well, but let us begin from the very scratch. So, semiconductors are those materials whose properties, electrical properties actually lie in between the properties of conductors and insulators. From the name itself it is also clear, semi means what? Half. So, those materials whose property lies in between the properties of the conductors and insulators are known as semiconductors. Now, how many types of semiconductors actually exist? There are two types of semiconductors, elemental and compound semiconductor. So, what are elemental semiconductors? What are compound semiconductors? From the name itself it is clear, elemental semiconductors are those which consist of only single atoms. Like here you can see the examples of germanium and silicon. So, in this case either it may be composed of the whole like atoms made from the germanium itself. While in the case of the compound, you may see over here I have written two examples, means it is a combination of two or more than two materials. So, it means elemental semiconductor, as I have told you, these composed of the single species of atoms, it may be of silicon, germanium or any other. While compound semiconductors is the combination of atoms for which particular elements? It may be elements from the group 3, group 5 or group 2 with the group 6. Some more compound semiconductors also exist which may be a combination of 3 materials or 4. Those are known as ternary and quaternary compound semiconductors. So, I hope now these two terms are clear to you. What do you mean by elemental and compound semiconductors? Now, what is the need of compound semiconductor? Why it is being required actually? So, if you see the behavior of the elemental and compound, you can see in the case of the compound semiconductor, the speed by which electrons actually moves, that is approximately 100 times higher than the speed of the electrons which are available in the case of the elemental semiconductors. So, that is a very important fundamental, and compound semiconductors are widely used in the formation and fabrication of high speed devices and those types of devices which require emission and absorption of light. So, these are the very important applications of the compound semiconductors. And let us discuss some of the compound semiconductors. See, in general you are aware compound means the combination of certain elements, but let us discuss 2 or 3 examples via which you will be able to understand which type of compound semiconductor is being used in which particular area. Like gallium arsenide. Gallium arsenide is the semiconductor which is commonly used in the formation of tunnel diodes, LED and laser. Second is indium antimonide, and this semiconductor, compound semiconductor, is commonly used in the formation of light detector. Next is cadmium sulfide, and this is commonly used in the formation of burglar alarm, street light switching and so many other applications as well. And in most of the cases you have seen that in the case of the television there is a fluorescent screen. So, zinc sulfide is used commonly in the television screens. So these are the certain points I have listed out over here, which type of compound semiconductor is used where. Semiconductor materials used for what? In the previous case, I have discussed about the compound semiconductor. Let us discuss some more about it. So, as you have already studied, semiconductors are the group 4 like materials, elements. In the group 4, you can see there are a number of elements. You have studied the periodic table. It starts from carbon, silicon, germanium and so on. Various elements exist over here. But each and every element cannot be used for the formation of the devices. Like carbon is not commonly used. One factor is it is very costly, but at the same time some refined form of carbons can be used in the semiconductors devices formation. But silicon and germanium, you see in most of the literature, you used to find this particular statement: silicon and germanium are the commonly used material for the semiconductors. So actually germanium was widely used in the earlier days for the semiconductor development, because of which transistor, diodes used to be fabricated. But silicon is the commonly used semiconductor material for nowadays, and it is used in majority of the devices like rectifiers, transistors and integrated circuits. So silicon is commonly used like semiconductor material. And the third thing about the compound semiconductor. So we have already discussed about the compound semiconductor, and I have discussed 4 different samples as well where it is being used. So compound semiconductors are widely used in high speed devices or the devices which require emission and absorption of light. You must remember these points, these are very important. Next is, what are the advantages of the semiconductor? You know how many types of semiconductors exist over there, what are the various applications, in which particular field it can be utilized, but you must be aware what are the different factors which make semiconductor to be used widely. What are that particular factors, features, because of which it becomes very fascinating. So first is highly portable device. The devices which is used which is being fabricated by using semiconductors, they are actually highly portable because their size is very small. These devices requires less input power. The power required for these devices is very less, that is also a major advantage. These devices are shock proof. This is also a very major advantage. And the devices which are made by using these semiconductor materials, their lifetime is very long, means longer lifetime is being provided by those devices. So these are the advantages which makes the semiconductor devices to be used widely. What are the characteristics? What are the characteristics of the semiconductors because of which it can be used and which makes it so much popular? Semiconductor materials, they have negative temperature coefficients. Negative temperature coefficient of resistance, it means if temperature is being increased, resistance decreases. So upon varying temperature, resistance decreases and conductivity increases. That is why it is said that semiconductors have negative temperature coefficients. At 0 Kelvin, semiconductors behaves as insulators. What does it mean? You have studied about the band diagram as well. Even I will be discussing it in today's lecture as well. But just to understand this, what are the semiconductors? In the case of the semiconductors, there is a forbidden band gap, energy gap in between the valence band and the conduction band. So what happened at 0 Kelvin, electrons which are available in the valence band, they are not getting sufficient amount of energy so that they can reach to the conduction band and they can participate into the conduction process. It means when there is no like movement of electrons from the valence band to the conduction band, there is no conduction. It means it behaves as insulator. At room temperature, which is 300 Kelvin, it starts conducting. But at room temperature, how it starts conducting? Because of the thermal energy which is being absorbed by the electrons, these electrons, some of the electrons you can say may be able to reach to the conduction band, and those electrons will participate into the conduction process. It means at 300 Kelvin, where conduction takes place because of the thermal energy. So, you can see, you can observe very small amount of current can like flow over there. It means at 300 Kelvin it behaves as a poor conductor. It is not a insulator, but it behaves as poor conductor. Electrical conductivity of semiconductors is very much affected by the addition of impurity. What is the addition of impurity? So, there is a process via which some impurities is being added to the pure semiconductor is known as doping. So, this is what? This is known as doping. So, if you add certain impurities to a pure semiconductors, that will definitely vary the carrier concentrations. The carrier concentrations, it may be a majority of electrons in the case of N type, it may be a majority of holes in the case of the P type. So, if there is an addition of the impurities, what will happen? Electrical conductivity will vary. So, this is also a very important point, you must remember it. Semiconductors do not follow Ohm's law. You have studied Ohm's law, but they do not follow Ohm's law. It means there is not a linear relationship between current voltage. So, when the current voltage relationship is not linear, it means it does not follow Ohm's law. Why silicon is preferred over germanium? Why to use silicon? What are the various factors because of which you can say that it is the preferred one? See, as I have told you, group 4 elements which you have studied in the periodic table: carbon, silicon, germanium, all these elements can be considered, can be like taken as the semiconductor material. And I have told you that some refined form of carbon can be used, but commonly it is not used as a semiconductor. But out of these two, silicon and germanium, there are certain factors I have already discussed, but why silicon is preferred one over the germanium? See, one factor is leakage current. Leakage current is less in silicon, which is the order of nanoampere, while in the case of germanium it is the order of microampere. So, here nanoampere is what? 10 raised to the power minus 9, micro is 10 raised to the power minus 6. So, leakage current is actually less in the case of the silicon, which makes it more attractive to use in comparison to the germanium. Second and very important factor, which type of material, even in general in our daily life, which material you would like to try to use, which are available in sufficient amount, which cost is already relatively less. So, silicon is available in more abundant amount on the earth, it is available in a large amount of earth. It means it can be easily used. At the same time, properties of silicon also like gives the add-on features, that is why this is commonly used. And one factor is about the germanium, which is the, you can say, the disadvantage for the germanium. Germanium actually becomes unstable at high temperatures. So, if there is a variation of even a small temperature, then its behavior looks like unstable. So, it means if we are using germanium for the fabrication of the devices, means definitely their characteristics, behavior will not be very much stable, and the factor is its unstable nature. So, these are the three important factors because of which you can say silicon is preferred over the germanium. Now, one question may come into your mind, why only group 4 elements act as a semiconductor? Why not 5? Why not 3? So, this is a very important question you may be asked a number of times. Why only group 4 materials act as a semiconductors? So, first and very basic thing is you can explain the chemical properties of group 4 materials are very much suitable for the doping. Via which conductivity is being increased and the extrinsic semiconductors used to be fabricated. So, it means their structure is very much suitable for the doping, and the another factor you can explain by the electron configuration. See, atomic number of silicon is what? Atomic number of silicon is 14. So, if you see the electron configuration, how to write it down? 1s2, 2s2, 2p6, 3s2. This is what? 2 plus 2 plus 6 plus 2. This is 12. So, in case of 3p, how many valence electrons are available? 2. But p shell occupies 6 electrons. So, it has a tendency to accept 4 more electrons, and it gives a very balanced covalent bonds can be formed if you are using group 4 elements, and that will gives a very stable structure. So, these are the 2 points. One is the its properties, it is very much suitable for the doping. Second is on the basis of the electron configuration, you can say group 4 elements can be used and it must be used as a semiconductors. Energy band diagram. Let us discuss the energy band diagram, because here you have to study the semiconductors, but at the same time, as you know that the semiconductors are those materials whose electrical properties lie in between the conductors and insulators. So, let us study the energy band diagram for conductors, semiconductors and insulators. Even I must say, let us revise this. See, in case of conductor, you can see there is a valence band and the conduction band. What is valence band? Valence band, which is generally occupied by the electrons. And what is the conduction band? Conduction band carries free electrons, which is actually responsible for the conduction process. So, in case of the conductor, you can see the valence band and conduction band may touch to each other or they may overlap. So, conductors are having very good conductivity if you compare in all these three on the basis of the conductivities. Means here electrons can easily participate into the conduction process. Second is the case of the semiconductor. What happens in the case of the semiconductor? You can see valence band and conduction band exist, but in between the valence and the conduction band, e.g. the energy band gap, the forbidden energy gap, which is approximately 1 electron volt. It means if we provide that much amount of energy so that electron can move from the valence band to the conduction band, then its conductivity will be increased and they will participate over there, but that amount of energy must be greater than this 1 electron volt or equal. So, it means conductivity of semiconductors would be less than the conductor. Let us discuss the third case, which is about the insulator. In case of insulator, you can see this forbidden gap, e.g. this is 5 electron volt, means if the electrons which are available in the valence band, these electrons require energy which is more than this 5 electron volt, then these electrons will participate into the conduction process. So, this is how in this particular case, in the case of the insulators, it is very difficult for the electrons to move from this valence to the conduction and can participate. It means if you compare all these three, conductors, semiconductors and insulators, then the conductivity of conductors is high in comparison to semiconductor and semiconductor in comparison to the insulators. So, accordingly you can understand its behavior. Now, let us study the classification of semiconductors on the basis of purity. One, you have studied on the basis of like which kind of structure is being formed, either it is an elemental semiconductor or a compound semiconductor. But in the same time, as we have studied that the conductivity of semiconductors can be increased. How it can be increased? By adding some impurities, and the addition of these impurities to the pure semiconductors is known as what? Doping. So, this doping is clear to you. This process is doping. So, it means now let us study the types of semiconductors on the process of purity. One is pure semiconductor and other is the impure semiconductor. Pure and impure, and in the case of the impure semiconductors, impurities have been added over here. You can see this diagram. Here, semiconductor is broadly categorized into two categories. One is intrinsic semiconductor, other is the extrinsic semiconductor. Intrinsic semiconductors are the pure semiconductors and extrinsic are the impure, means here impurities is to be added. And depending upon the types of impurity, whether we are adding pentavalent impurity or trivalent impurity. If pentavalent impurity is being added, the type of semiconductor is known as N-type semiconductor, and if pentavalent impurity is being added, trivalent impurity is being added, it is known as a P-type semiconductor. Here some of the pentavalent impurities I have listed over here: phosphorus, arsenic and so on. Trivalent impurities, group 3, gallium, boron, indium. In case of N-type, where pentavalent impurities have been added, here concentration of electrons will be very high in comparison to the holes, while in second case where we are adding trivalent impurities, the concentration of holes will be very high in comparison to the electrons. Let us study it in more detail. What do you mean by intrinsic semiconductor? Intrinsic type of semiconductor which is pure. An intrinsic semiconductor is made up of by a only single type of elements. You can see it may be made from the silicon atoms or from the germanium. See, you can see one particular structure over here. See, each and every silicon atom is being surrounded by 4 silicon atoms over here. So, what happens, because you know that in the case of silicon 4 valence electrons exist over here. So, all these 4 electrons for the center one silicon, they will form a covalent bond with the neighbors, you can see, and it will form a stable structure over here. So, what happens in the case of intrinsic semiconductors? The concentration of electrons will be equal to the concentration of the holes, means N is equal to P. Because if one covalent bond breaks, you can see this particular case, this. If one covalent bonds will break, means if we are varying temperature, if we are providing some additional energy, then what will happen? How many electrons will be free? 2 electrons, because by the sharing of 2 electrons, one covalent bond is formed. So, when an electron is free and this particular electron moves from its position, if this is an electron, it moves from its particular position and reaches to some other point, then a vacancy is being created and this vacancy is known as hole. So, this is how the electron hole pair generation takes place. So, what is the generation of electron hole pair? When an electron leaves a space, a hole is being created and this is known as the generation of electron hole pair. What is recombination? When electron recombine with a hole, means whatever the vacancy was available, now this hole will disappear and that is known as a recombination. The third term is lifetime of charge carrier. So, what is the lifetime of charge carrier? The duration for which the carrier is being available before the recombination is known as the lifetime. Now, what do you mean by the extrinsic semiconductors? Extrinsic semiconductors are those semiconductors where some impurities are to be added, and this process of adding impurity to the pure semiconductor is known as doping. and accordingly 2 types of semiconductors have been formed, which is known as a N-type semiconductor and P-type semiconductor. N means by adding pentavalent impurities which have 5 valence electrons, P-type semiconductors which have trivalent impurity, which is being formed by the addition of trivalent impurities which have 3 valence electrons. See, pentavalent and trivalent impurities, as I have told you, accordingly N-type and P-type are being formed. You can see in this particular diagram, here it has been shown N-type semiconductor is being formed by adding a pentavalent impurity. It is having 5 valence electrons. So, what happened? 4 electrons will form a covalent bond with the neighbor silicon and 1 electron will be available free. So, in this case, what will happen over here? In the case of N-type, means each and every pentavalent impurity is contributing 1 electron, and usually 1 atom of impurity is being added to the 10 raised to the power 8 atoms of the semiconductors. It means what will happen over here? In N-type semiconductor, the concentration of electrons will be very high in comparison to the holes. While in case of P-type, where trivalent impurity is being added, trivalent having 3 valence electrons, means to complete its octet it has a tendency to receive 1 electron. It can receive, means this is a kind of acceptor impurity because it can receive it. It means each and every acceptor impurity is contributing a hole. So, here in P-type, the concentration of holes will be very high in comparison to the electrons. So, I hope now it must be clear to you what is semiconductor, how many types of semiconductors are there, means you have studied 2 different classifications. One classification because of which you have studied about the elemental and compound semiconductor, and the second is the intrinsic and extrinsic semiconductors. So, these 2 types of semiconductors must be clear to you. What are the advantages, which type of semiconductor is used in which particular field, and then we have discussed about the classification of semiconductors on the basis of purity. Means one is pure semiconductor, other is impure, and even in the case of the impure semiconductor, 2 types of semiconductors exist. 2 types of semiconductors which is known as N-type semiconductor and P-type. And you can easily recall the things, means in N-type, since the pentavalent impurity is being added, means each and every impurity is contributing an electron. So, concentration of electrons will be high in N-type. So, majority charge carriers are electrons in N-type semiconductors, while majority charge carriers are holes in P-type. Thank you so much.